Hello everyone, my name is Xiaoyu. I'm a data scientist at Microsoft. Today, on behalf of my co-authors, I'm very happy to present you our paper of evolving software to be ML-driven utilizing real-world A/B testing, experiences, insights, challenges. Nowadays, artificial intelligence have reached news headlines. Applications like facial recognition and autonomous driving has drawn people's attentions. But today, I'm going to talk about at Microsoft how we internally democratize artificial intelligence and machine learning to our internal Windows developers. I'm going to talk about how we evolve Windows features to be ML-driven by introducing two case studies. The first one is Windows Update, and the second one is Windows System-Initiated User Feedback. In both cases, we used machine learning to replace existing rules and heuristics so that they can improve over time. As we democratize artificial intelligence and machine learning to internal Windows developers at Microsoft, we built a platform called the Windows Intelligent Services Engine, or WISE in short. WISE is an end-to-end platform that intends to ship embedded machine learning models to the Windows operating system. It captures the whole life cycle of machine learning models, including training, deploying, inferencing, experimenting, monitoring, improving, and management. At high level, WISE highlights several important use cases and functionalities to internal Windows developers. First of all, WISE provides a set of commonly used data features available for Windows engineers so that they can reuse those important and useful features for their various applications. In addition, the cloud-side machine learning training and client-side inferencing are an integrated experience in WISE. Thirdly, WISE leverages scalable and secure deployment manners for new and updated models. WISE embeds machine learning functionalities according to Microsoft Responsible AI principles so that internal Windows developers can make their AI applications more responsible. Last but not least, WISE also connects with the Windows experimentation platform so that Windows developers can measure the causal impact of their features very easily. All in all, this end-to-end experience in WISE really removes the complexity of disparate technologies for our internal Windows developers. The first case study I'm going to talk about today is the ML-driven Windows Update. Windows Update is a process that keeps the Windows operating system secure and with the most up-to-date functionalities. You may recognize this top figure of a rebooting process during the Windows Update. In this case, we leveraged the embedded machine learning model on the Windows operating system client that tries to decrease disruptions by predicting the best timing for reboot. This machine learning feature has gone through several rounds of A/B testing. The first round happened on Microsoft internal devices with the focus on feature quality to catch bugs early. Later on, we did experimentation on Windows Insiders to further validate the quality of this machine learning feature. Lastly, we leveraged the controlled feature rollout technology to progressively release this machine learning feature to the general retail population. Now, Windows users can enjoy this feature during the Windows Update process. The second case study in our paper is the ML-driven SIF, where SIF stands for System Initiated User Feedback in Windows. SIF is an important survey channel that collects valuable feedback from Windows customers. The figure here shows an example SIF question. In this case, we wanted to minimize disruptions to Windows customers during the survey toasts. We leveraged WISE to build and ship an embedded machine learning model to the Windows operating system that predicts the best timing for the survey pop-up. Similar to the Windows Update case, this feature has gone through multiple rounds of A/B testing in both Microsoft internal population and among Windows insiders. The experiments showed very promising early results. Our experience is that in building ML-driven software, machine learning and A/B testing technologies really work together. First of all, safety is always top concern for any software. A/B testing can uncover bugs and quality issues in very early stages. Secondly, in developing ML-driven software, sometimes a complete in-house testing is not feasible. A/B testing really complements that by seeing unforeseen situations and inputs. Thirdly, ML-driven software often have very complex interactions with other software as well. A/B testing can isolate issues in a causal way in a very complex system. Lastly, human interactions are one of the key components for ML-driven software. A/B testing provides an important way to measure unpredictable user reactions. We shared several insights in our paper as we work on building ML-driven software over the years. First of all, make your ML model an addition to existing rules or heuristics. This can give you an early win for your ML feature without signing up for a lot of work. As a result, it reduces both the engineering risk and the organizational risk in your company. Secondly, we observed that machine learning can sometimes cause feature-level sample ratio mismatch, or SRM, in your A/B testing. We recommend to use overall success matrices in addition to scenario-specific matrices. Thirdly, related to our first point, we recommend to make your ML models updatable but separate from other code updates. This can isolate the risks during update and expedite your engineering process. Lastly, our experience is that it is very important to make your models explainable. This can build trust from your stakeholders, and also simpler glass box models can run faster at any hardware configurations. In closing, I wanted to share some of our future directions considering real-world challenges we observed over the years. Fairness in machine learning applications have drawn much attention recently. Our experience is that it is very important to pick up the right definitions of equality in your application. This continues to be a challenging social technical effort in machine learning. Secondly, Windows has a large user base. The notion of federated learning with local privacy is a promising approach. It shifts some computations to the client while protecting user privacy. We are going to continue to evaluate this approach for Windows machine learning applications. Lastly, it is commonly understood about the population discrepancy between a pre-release population and the general audience retail population. It continues to be an interesting and important topic that how we can use insights from pre-release population to generalize to the retail population. This is a common topic for both machine learning-driven software as well as traditional software. Overall, these real-world challenges let us keep improving our system so that customers all around the world can enjoy a better Windows operating system. That concludes my talk today. Thank you all for joining. I'm happy to answer any questions. Thank you.
All right, so welcome everybody to the session on social equality and fairness. This is actually the first of 2 sessions on this topic. My name is Jill Atley and I'm the Associate Chair for today. And with me is Xiaoyu Chai, who is this author of this paper. So if you do have questions, I do hope that you will put them in the chat. And we do have one first question. So this is from James Davis. Windows previously had hand-coded behaviors for update and feedback. Can you comment on behaviors the ML approaches exhibited in your case studies that were not already present in the hard-coded versions?
Yeah, that's a very good question, James. Thank you for asking. So as I mentioned in our paper, which is that this machine learning driven approach is built on top of the hard-coded behaviors. So internally, we have this so-called courtesy engine, which is hard-coded rules, and that honors the present or not present behaviors from the users. And on top of that, our machine learning model builds another layer of checking on top of the hand-coded behaviors, so that we are really sure that it is really the best time to kick off the update process. So you can see that this is an additional layer on top of the existing rules or heuristics. I hope that answers your question, but thank you for asking.
All right. And so I'm gonna ask a slightly twisted question, and it probably relates to the session and some of the other papers in this session. So I don't know whether any of your studies looked at the demographics of the users in the two case studies, and in particular the SUIF study, right, where you're trying to get user feedback on the product.
Yeah, very good question, Joanne. So we sort of have some demographic information because that's highly tied to user self-submit, right? So we don't, on top of our head, collect the demographics from the Windows machines. But if users self provide that information to us, we do have that information with user consent. And then you're right that we do look at from the demographic perspective about how users behave and what kind of ratings they submit on, based on different demographic groups. And we want to make sure that the machine learning solutions we develop is fair across those demographic factors as well. So internally, we have this responsible AI initiative that's led the whole Microsoft company-wide initiative. So every machine learning solution we develop, we will go by this initiative and reviewed by our internal law groups and then our internal PR groups to make sure that our model does not create significant biases towards certain groups of underrepresented population.
Exactly. And just a quick follow-up, do you have enough data to suggest whether there are any differences, like you have enough data to disaggregate by gender, by age, that indicates there are differences, especially in the SUIF case study?
Yeah, good question. So if you recall that the Windows total population in the scale of billions, so yes, it's a small proportion of users who actually submit the feedback, but even that smaller proportion is a big count. So we do see some statistically significant differences among different demographic groups from that perspective.
Okay. That would be interesting to hear about next year.
I will come back.
Exactly. So there is another question from the audience. Dai Lin, is there another layer of rule-based failsafe on top of the ML decisions to avoid unexpected behaviors?
Yeah, thank you, Dai. So good question. So as I mentioned to the question to James, that the machine learning solution is actually built on top of this rule-based fail-safe heuristics. So internally, we have this courtesy engine to make sure that for both cases, for Windows Update and for the user feedback, we don't annoy users based on certain rules at all. Even if the machine learning says, yes, this is a good timing, but if that rule says no, that is a veto process. We want to make sure this is no interruption to user experience at all.
Awesome. All right. So, so can I ask sort of, what you've talked about today, what you've written about is from 9 months ago. Are there any advancements since then, right? Like, is there anything else that you are? Is there anything else that you are exploring right now that you're willing to share?
Yeah. Yeah, so as I mentioned in the paper, that we are a centralized solution to Windows operating system as a whole. So we don't just support this scenario or that scenario. We support all the intelligent features in the Windows operating system. So we do have some good features, intelligent-driven features for Windows that's coming out, and we do support them as well. So stay tuned. You'll see them.
Excellent. All right, so James Davis asks, one of your recommendations is to make the ML model an addition, right? So questioning how to interpret this, does it mean that you recommend starting with a hand-coded version and then building the ML on top of that? Or does it mean that you recommend integrating ML approach as one of several strategies?
Yeah, so if I interpreted your question correctly, I would say that it really depends on the application you are working on. So for example, if you're building a autonomous driving for Tesla, maybe you don't want to do the hard-coded rule first. You want to do this end-to-end machine learning experience. But for some of the existing software, that a lot of teams already have this existing rules. Our personal experience is that working with those teams, building machine learning on top of that would give you a very good start, both in terms of engineering and in terms of your organizational risks. We mentioned in our paper that when we worked with a lot of teams, when they heard about machine learning, they are very excited about it. But when we lay out the exact work to be done, they may have some frown face after talking to us. But this incremental step really reduce the risk that they have this incremental success so that they can show to their leadership and then give us more resources to make this feature much more better. So I think that is really tailored experience depending on your application at hand.
Awesome. So does that answer your question, James? I think yes. All right. Let's see. I have something here about the scenario-based models versus traditional ML models, and that the ML models best support the advancements that have been made already in explainable deep learning models. Do you want to say anything about that and how you're making use of that?
Yeah, totally. So as I mentioned, that internally we have this responsible AI initiative, and interpretability is definitely one of the 6 pillars in Microsoft. So we do take that interpretability very seriously for every machine learning model we make. So in our pipeline, after we make the model, you will have the integrated experience for interpretability. And then there are a lot of open source tools that's available in the research community, and we leverage those tools as well. So in addition to interpretability, we also look the models from the reliability perspective, from the fairness perspective, from other accountability perspective. So we have to make sure that our model pass those scrutinies from both law and then PR perspective.
Awesome. So do you want to, any last takeaways that you want to give before we thank you?
Well, I mean, we are working on a lot of interesting features. We really look forward to you enjoying the features and sending us more feedback. And then we look forward to see you again next year.
Awesome. Thank you. And you can continue the discussion in the discussion room.
Yeah, thank you, Joanne.